In this video, we're going to think about interactions between objects in an object-oriented program. Object interactions are fundamental to the way in which every object-oriented program works, but they can be a little tricky to understand or visualize. So this video is intended to help with this concept. We will be using the BlueJ IDE to illustrate the concept, and will only assume that you are already familiar with writing classes at a very basic level. In a typical class diagram for a program, there will be multiple classes, but we would not normally expect to see the class diagram looking like this, with no links or arrows between any of the classes. The normal situation will be more like this, where pairs of classes have arrows between them. Some classes will have multiple arrows leading out from them, like class A in this example, and some will have multiple arrows leading into them, like class D in this example. The arrow represents what is more formally called an association between classes, and it tells us that objects of the class at the start of the arrow will interact in some way with objects of the class at the head of the arrow. Unfortunately, from the diagram that's about all we can tell, which is not actually very much. The most common sort of interaction arises where an instance of one class calls a method on an instance of another class. Method calling between objects comprises the majority of activity at runtime within an object-oriented program, and uses the typical dot notation you should already be familiar with. An interesting point to think about is that the object whose method is being called, the module object in this case, has no way of knowing anything about the object that is doing the calling. That is why the association arrows in the diagram are usually in one direction only. Objects of the calling class know about objects of the called class, but not vice versa. Indeed, methods of the called class might be called by objects of lots of different classes, as indicated here in this class diagram, where there are two association arrows pointing to the D class. Instances of the D class will respond to method calls from both and won't know whether it is an instance of the B or the C class that is calling them on any particular occasion. To make the discussion of object interactions a bit easier, let's give informal names to the two classes involved in an association. We will call the class at the start of the arrow a client class, and the class at the end of the arrow a server class. To help you remember which is which, you can think of it as that objects of the server class provide a service. They do something for the client objects. A server object's method is called, and it acts. But as we have noted, unlike human servants, server objects don't know who their clients are. Despite their not normally appearing on class diagrams, you might be able to appreciate now that library classes are typical examples of server classes. They provide a variety of services to any program that needs them and don't need to know anything about their various callers. A particular example of a server class is string. Lots of different classes will make use of string, and its objects simply have to respond appropriately whenever methods such as length or equals are called on them. The same will apply to other library classes like ArrayList with its add and size methods, and HashMap with its get and put methods. Library classes are used by thousands of other classes to take on some of the workload of the overall program. They provide a service. When we write programs, instances of some of our classes will respond to method calls from instances of other classes, and the association arrows will tell us which classes are the responders, the server classes, and which are the initiators, the client classes. In fact, it's perfectly possible for instances of one class to be clients of another, but servers of a third class. In this example, instances of class client make calls on instances of class mixed, so mixed is a server class in those interactions. But the association arrows also tell us that instances of class mixed call methods on instances of class server, so mixed instances act as clients in those interactions, meaning that mixed is a server to the client class and a client of the server class. It can be a little tricky to visualize object interaction, but let's have a go with this project. Firstly, we create a server object on the BlueJ object bench. If we now call its doSomething method, we're actually simulating the role of a client, and the server object is providing a service to us, in this case simply printing a message. The code equivalent for our interaction is server1.doSomething. Of course, normally this method call would be written in the source code of any classes that need to interact with instances of the server class, And that is exactly what we have done here in the interact method of the client class to show how a client object would interact. When you look at just the source code line of a method call, you only directly see the involvement of the server object, represented by the variable name on the left of the dot. To see the involvement of the client object, you have to remember that the call is being made from within a method of the calling class, the method interact in this particular case. Of course, that method itself will have been invoked on the client object, and that object is now asking the server object to do something. That is in essence how all interaction between objects takes place within a program. A method is called in one object, which calls a method on another object, and so on. So notice that the server's doSomething method actually calls a further method, println, on the system.out object, and no doubt that object will be calling methods on yet more objects in order to achieve the overall task of printing something. In effect, many tasks are achieved by chains of method calls from one object to another, and so on. To show this in practice, let's create an instance of the client class. We can see from the inspector that the client object has a server object ready to use, which was created in the client's constructor. If we call the client's interact method, then it will interact with the server object to print a message. To get a full understanding of what's going on, let's use the BlueJ debugger to step through the process. We put a breakpoint inside the interact method so that the program will pause when it reaches this point. Then we call interact on the client. When the program pauses, we are inside the client object just before it calls doSomething on the server object. If we step into, we see that control has now passed to the server so that it can complete its action. Stepping on takes us to the end of the doSomething method, and then a further step to the end of the interact method. In summary, we've asked the client object to interact with the server object, which it did by calling the server object's doSomething method. So the client object interacted with the server object, and that's the fundamental basis of all object interactions. In this video, we've looked at what the association arrows on a class diagram tell us about the roles of the different classes within a program in order to gain insights into object interaction. Some classes provide services to others, just like the string and ArrayList library classes do, while some achieve their tasks by using the services of other classes. Most common of all, however, are classes that sit somewhere in the middle, providing services for part of the time and invoking them for the rest. Object interaction is fundamental to all object-oriented programs.